Hello guys, on this video we're going to work with analog signals, and what we're going to be doing is going to be sending a certain amount of voltage to our MSP430, and we're going to make it do this. So as you can see, it slowly gets brighter and then slowly fades away, kind of simulating a heartbeat. So these analog signals, and they really open up a new world of possibilities for our MSP430, and we really need to practice these kind of functions, and we really need to understand them. So let me show you the code that you're going to be using to do this, and good luck. So first, this is half of the code. This is not the whole thing, but first let me start explaining what is going to happen. So here, really straightforward, really easy. If we set up a constant, which is analog pin, is going to be the same thing as saying pin 14, which is the green LED. Then we jump into the setup. Here, we should set up the pin 14 as an output, because it's the one that we're going to be using. But because the pin 14 is an analog pin, we do not necessarily have to do it. So I'm not going to do it in this case. Then we jump into the loop. We open up a for loop. Then we can see that we start with I from 0. We add 5 units to I until we end up with 256. Now we jump into the analog part. Analog write. What is analog write? Analog write is pretty much really close to digital write. If you remember, digital write has two parameters, parameter 1 and parameter 2, just as analog write. Parameter 1, it's which pin we're going to be sending the voltage to, and parameter 2, it's high or low, which pretty much is on or off. So on analog write, the thing that we can do is, instead of on or off, which is 0 volts or 3 volts, we can do 0 volts, 3 volts, and everything in between. So here what we're doing is we're sending a certain amount of voltage to the pin 14, and that certain amount of voltage, it depends on which cycle are we in. We start from 0, then we go into 5, then 10, 15, 20, and we keep going that way until we reach the 256 or more. 256, sorry. Then we go into the delay. We keep it that way for 30 milliseconds. And as you can see here, if you compile and upload this code, what is going to happen is going to get brighter, but then it's suddenly going to turn off. So we don't want that. We actually want to slowly fade away. So in that case, we need to add another piece of code. And now we will use this one. As you can see, it's pretty much the same thing, constant. Here I set up the pin as an output. I can erase this, but I'm going to leave it there. Then same thing, for loop, analog write, delay. So now we jump into the part that is going to actually make once the LED is at full brightness, we're going to make it fade away. So we make another for loop. Now we start from I being equal to 255, and we're going to start subtracting 5 units until I reaches 0. So same thing, analog write, analog pin, then the value that the voltage that we're gonna be sending, it's I, and the delay is gonna be 30 milliseconds. I don't think I mentioned this, but really important thing that you need to know: 0, it's equal to 0 volts on analog write. On analog write, 0 is equal to 0 volts. Now 128 it's equal to 1.5 volts, and 256 it's equal to 3 volts. So if you want to send another kind of voltage, just do the math. As you can see, pretty much 256 is the full voltage. 128 half of 256, so it's 1.5 volts, and 0 is just 0 volts. So whenever you compile and upload that code, you're gonna end up with this. which is pretty cool. And on the next video we're gonna keep using analog signals, but it's gonna get a little more difficult and a little cooler. So good luck, have a good day.